Welcome to Unit 13. We look at Hopital's rule. It will solve all our agonies with limits and a fantastic rule. It also will answer the question, what is 0 to the power 0? So let's look at the rule first. And we always deal with indeterminate forms like 0 over 0 or infinity over infinity. Or 0 to the power 0, we will just see that. And in that case, when we have the limit x goes to a, f of x over g of x, we can compute that by just taking the derivatives of f and the derivative of g. So x goes to a, f prime of x, and g prime of x, if f of a is equal to g of a is equal to 0, or if f of a is equal to g of a is equal to infinity. So this is the rule, a very simple rule. We differentiate the top, we differentiate the bottom, and we get hopefully an answer. Sometimes we have to do it several times. Remember that function, sinus x over x, sinc x. We have seen a fundamental theorem of trigonometry told us that what the limit is. Now, this is an indeterminate form of the form 0 over 0. So when x is equal to 0, then we have a indeterminate form 0 over 0. And we can use Hopital. So Hopital tells us that sinus x has the derivative cosine x, so we have the limit x goes to 0. Let me just write down the whole thing. Sinus x over x is the limit x goes to 0 cosine x. That's the derivative on the top. And on the bottom we have 1. So that's now not the problem, because when x goes to 0, this is 1. And so that's our answer. It's that simple. By the way, why is Hopital true? It's comically simple, because what we have is if you have fx plus h minus f of x over gx plus h minus g of x. You see, when you write that, and f of x and g of x are both 0, that goes away. And so the limit when h goes to 0 is this is f of x over g of x. This is the limit, and h goes to 0. F of x plus h, g x plus h. And so that's the limit we actually want to know. But if you divide this by h, and here also by h, this is goes to the derivative of f, and this goes to the derivative of g. So this is the limit x goes to 0 f prime x over g prime x. So it is so simple, but Hopital, who by the way was doing that for Bernoulli, he was a kind of a contractor for Bernoulli, wrote down a textbook and his name stuck. So that's why it's called Hopital. Sometimes it's called Hopital, sometimes the S is left away. I actually prefer Hopital because you want to bring something which is broken to the hospital. So that's what we do. Okay, to get more than 20 views for this video, I should have called the title, what is 0 to the power 0? Actually, this was a question which was asked to my middle school teacher, and the teacher could not answer the question. I thought this is actually kind of interesting. And then in high school it was asked the high school teacher could answer it. So there's a good answer to this. So this doesn't make much sense here, because anything to 0 is equal to 1, and anything to 0 to a is equal to 0. So we don't know what is happening, but this doesn't make sense. But we can say, what is the limit when x goes to 0, x to the x? That's now a well-defined question. We can answer this. Maybe the limit doesn't exist, but we will actually see the limit exists, because what we can write is, this is the limit x goes to 0, e to the x times log x. And now we just have to actually understand what is x times log x. The limit when x goes to 0, x times log x. So the question about x to the power x was reduced to this question. Let's answer this question instead. But it's not of the form 0 over 0 or infinity over infinity. We have to write this first in a different way. So we can write this is actually the same thing than log x over 1 over x. That's kind of that's a trick. And now this goes to infinity when x goes to 0, and this goes to infinity. So now we have an indeterminate form of the form infinity over infinity. And also here, when we have infinity over infinity, this is orbital applies, and we can just take the derivative. So bring it to the hospital. Then x goes to 0. That's the log x has 1 over x. This derivative is minus 1 over x squared. We can simplify that. This is 1 over x times minus 1 over minus x squared over 1. So this is minus x. And so it's always limit x goes to 0, limit x goes to 0 minus x, and that's no problem. That is equal to 0. So that goes to 0. X goes faster to 0 than log x goes to minus infinity. By the way, that was the entropy function. Minus x times log x is the entropy function. So in this case, that goes to 0. So this implies that x to the x, which is e to the x times log x, this goes to 0, right? Goes to 1. So x to the x goes to 1. The answer to this question here, this is going to 1 if x goes to 0. And we should always kind of then, in order that this makes sense, is maybe take the absolute value of x here, so that we can go from both sides, from the left or from the right. Okay, this is a beautiful problem. Absolutely no problem when x goes to 0, this goes to 0, this goes to 0. So this is of the indefinite form 0 over 0. No problem, we can apply orbital. It's a broken function. Bring it to the hospital. So we have this, and then we just take the derivative on both sides. So it's e to the x, e to the 3x times 3. And when x goes to 0, there's no problem now. This is equal to 1 over 3. See, this limit is not an indefinite form. This limit exists, is 0, is 1. This limit exists, and it's 3. So that's 1/3. Let's look at this one. So this is a case when we go to infinity, when x goes to infinity. So this is part 5. The limit when x goes to infinity, 3x cubed plus 5 over 7x cubed plus 7. And in this case, this is infinity over infinity. This is an indefinite form, infinity over infinity, so that orbital works. We can take the derivative. So take the derivative. When we take the derivative, we get limit x goes to infinity, and then we have 9x squared over 21x squared. Now we can really kind of cancel this and see this is equal to 9 over 21. So computing this limit with the h definition would be quite a pain. So it would be kind of just like fixing a bone yourself, right? Bring it to the hospital. Okay, number 6 is this problem. What is limit x goes to 0, x to the 10 minus 1 over x minus 1? Just go bring it to the hospital. So this is 10x to the 9 over 1, and that goes to 0. But we have computed such a thing, and that was not true. What is wrong? So this is not, this is a trap. So this is not, you're not sick. This is not a broken bone. at x equal to 0, this is no problem. At x equal to 0, we have a limit x goes to 0, x to the 10 minus 1 over x minus 1 is no problem because it's not in indefinite form. So this is equal to 1. For x equal to 0, that we can just plug in 0 and we get minus 1 over minus 1, which is equal to 1. So that was just a little trap here. So what we actually want to do is we want to compute the limit x goes to 1 instead. 1 is a broken bone. So what we have done before, we have healed it. By writing it as x to the 9 plus x to the 8 plus x to the 7 plus x plus 1. So that was the healing thing, but that's kind of just something you might not remember, and then when you see it, when x goes to 1, you can compute it. This goes to 10 when x goes to 1. Now that was just a reminder how we have done it before. Now we can forget about all these tricks here and just say limit x goes to 1, x to the 10 minus 1 over x minus 1. That's of the indefinite form 0 over 0. Now we are in business. Now we really are sick. Now we can bring it to the hospital. And now we can take the derivative. So limit x goes to 1, 10 x to the 9 over 1. And now when it's no problem now, this is just equal to 10. So we see that this same answer than we had before, it can now be obtained much easier by just bringing it to the hospital. Okay, first check, is it really a problem at x equal to 0? Yes, it is a problem because we have 0 over 0. So this is really an indefinite form 0 over 0. So bring it to the hospital. Broken bones, we bring it to the hospital. This is the same thing, then x goes to 0 and then minus sinus x over 2x. And well, again we have a broken bone. Not healed yet. So bring it to the hospital again. And so this is the limit x goes to 0 minus cosine x over 2. No problem now, because now we can take the limit, so this is equal to minus 1. So sometimes we have to heal it twice, sometimes we have to bring it twice to the hospital. Here we could also have seen it just with the fundamental theorem of trigonometry, that this sinus x over x goes to 1. Okay, last but not least, we have an example again, and we check first when x goes to 0, this is really of the form 0 over 0. So this is an indefinite form, 0 over 0, so we can use Hopital. So we take Hopital, and so this is the limit x goes to 0. You might remember how to take the derivative of 3 to the x. Right, so this is 3 to the x times ln log 3 over cosine x. And now when x goes to 0, this is no problem, which is log 3. 1, which is log 3. Okay, that's it. And we look at more examples in class.